So in SC15 we look at equilibrium. You will notice if you look at the advanced information that they've taken CC12 off, which is when we first looked at equilibrium, but they've kept SC15 on, which means they can still ask you about equilibrium even though combined students won't be asked about equilibrium. When you guys did equilibrium 6 markers for me, you absolutely smashed them. So please just make sure you revise it. You were all able to do it at the time. Just look back over it. But the one thing I want to point out from those equilibrium 6 markers, a kind of common source for error, the reaction that we looked at in a bit more detail was called the Haber process. And it's about the production of ammonia. And in the Haber process, you used a pressure of 200 atmospheres, you used a temperature of 450 degrees Celsius, and you used an iron catalyst. Now they don't have to ask you about that reaction, they can ask you about any reversible reaction. And what they've done in the past is they've picked a different reversible reaction and they've told you the conditions, and they've asked you to comment on yield, and they've asked you to comment on rate. And in one instance, they told you that the pressure that was used in this other reaction was 10 atmospheres. And they asked you to comment on rate, and they asked you to comment on yield. Now, if students saw this 10 atmospheres, compared to the pressure they were used to from the Haber process, they thought that this was a low pressure. And yes, of course, it is lower than the pressure that is used in the Haber process. But atmospheric pressure, the pressure that you experience on a daily basis, atmospheric pressure, is only 1 atmosphere. So in this reaction, they are using a high pressure. It is higher than normal atmospheric pressure. Anything higher than 1 is going to count as high pressure, even if it's not as high as what's used in the Haber process. So when you were talking about this reaction, whatever reaction it was, let's just say A plus 2B goes to C, let's just make up a random reaction. When you're talking about this pressure is higher than atmospheric pressure, so it does count as being a high pressure. And if you're using a high pressure, it favors the side with the fewest molecules. So on the left hand side, I've got 1 A and 2 B's, I've got 3 molecules. On the right hand side, I've just got 1 molecule. So this high pressure favors the side with the fewest molecules, and my high pressure is going to promote the forward reaction, and it's going to increase the yield of C. Okay, what a lot of students said that year was, oh, 10 atmospheres, that's low. Because it's a low pressure, it's going to promote the reverse reaction. So just be clear, anything higher than 1 is going to count as a high pressure. Beyond that, just read back over the notes on equilibrium. There's a couple of model answers in your booklets. Just look at how you need to structure a 6 marker on equilibrium. The other thing that comes up in SC15, fertilizers. Again, it's just a little bit of content. It's relatively easy. There's a bit about batch process and continuous process. Have a look at that. I mean, they've never asked a 6 marker on it before, but they could. And again, like the kind of life cycle assessment and stuff like that, it's not difficult content if you've read over it and you know some of the information. So again, please don't overlook it just because it hasn't been asked before. So they talk about batch process, they talk about continuous process, it's all in your booklet. And then the other thing is fertilizers themselves. You've got nitrogenous fertilizers, which contain nitrogen. And you need to be able to write an equation between the reaction of ammonia and sulfuric acid, and ammonia and nitric acid. Again, they're straight from your notes, so please do learn them. Any equation that comes up is going to be at least 2, if not 3 marks. Those ones are specified on the course in that chapter, so just make sure you know how to write them.